Hello everyone, here's Ray from UCSB. I'm going to introduce DOC2PPT, automatic slide deck generation from documents. This work is also collaborated with Microsoft Research. As the title and the following figure, DOC2PPT is to generate a slide from an academic paper. As a multi-model summarization task, DOC2PPT involves text summarization, figure retrieval, and the most important, combine all output content and format as hierarchical multi-page, such as slide deck. We first build the dataset to learn from. For those 2 years, most conferences are hosted virtually, where we can collect many paper slide pairs from these CV, NLP, and ML conference. We collect around 6,000 in total and split them into 4.6 thousand for training and 600 for each validation and testing. Since those slides are originally in image format, we need some preprocessing in advance. For paper, we just use science parse and PDF figure to extract text and figure content. To extract text content from the slide, we adopt optical character recognition, aka OCR, to recognize it from a slide image. Then we have to match sentence from slide to paper. Similar to extractive-based summarization, we assume that each sentence in slide can be retrieved from the paper. We used a pre-trained BERT language model and find the most similar sentence between each other as the matching pair, where you can see these two examples. Dataset contains 768 patients and records features like glucose, blood. Apart from text, we also match the figures, and we use the CNN feature to do similarity matching. Here is the cases of matched figures from paper in slides. But figure matching is not that easy as text, since there can be two cases making it poor. Partial matching, where sometimes we only show incomplete figures in slide, and also different expressions of table to emphasize the empirical results. Currently, we have 50% F1 score, and we leave a better recognition as future work to improve the figure matching label. For testing, we need a non-noise set, so we apply human label as a golden testing set for fair evaluation. Here are some other steps for processing the slide. As people will use animation during presentation, we have to remove the progressive pages. We use an intuitive way that we remove the page with most text content are covered. So if the OCR cover rate is more than 80, we treat it as a progressive page and remove it, and we only keep the last one. So this method achieves more than 90% accuracy, and we can see two successful cases on the below. Since we consider DOC2PPT as section-based, where we generate pages for each section and combine all of them as the final slide deck, we do the matching from text in page from slide with text in paragraph from section to decide this page belongs to that section. We know that slide does not always follow the same section order in paper, but we consider this section-based with continuity first, since it is difficult to generate for the whole slide from scratch at one shot. And here is an example for the section matching between paper and slide. We summarize our dataset building process. Firstly, OCR is applied to extract text content from slide, and then matching between paper and slide by Roberta or by the BERT language model, and also match figure by the similarity of CNN features. And we remove the animation, or we say the progressive page, by the OCR cover rate. And finally, we do section matching to formulate as section-based. And here is some number of our collected datasets. And if we plot out, we can find that the distribution over training, validations, and testing sets are very similar. Although there are so many presentation ways as slide, we can actually learn from them to perform DOC2PPT. And let's talk about the method. We imitate how human does and consider the recurrent extractor to build the slide step by step, where a progress tracker, which is a GRU, will output an objective token, page token, or section token. To decide for the current state, we will put the object, move to next page, or move to next section. For example, we first meet an object token. So we know put an object including a sentence from the current section or a figure from all in paper onto this page. For object token, we do the classification between the hidden state of progress tracker and object set, and then decide to sentence one first. Then it checks to the second object token and put sentence 2 here. We meet the page token this time and have to move to the next page. So you can see the page 2 here. In page 2, we also put 2 objects. Note that not only text but also figure can be selected, so that our slide can have both sentence and figure presented. After 2 pages, there is the section token, which means that we finish the first section and can move to the next one. And keep doing it until all sections are done. In this way, the progress tracker will track the architecture of the slide, including the page and also the section. Finally, we combine all of them as our output slide deck. We also consider hierarchical slide extractor, aka HSE. HSE adopts different elements to model different levels of architecture, where one for section, one for page, and one for object as the progress tracker, and use the same method to pick sentence or figure up to put in a slide. We propose 2 additional modules to further boost the presentation of our output. Text figure module is a joint embedding between text and figure, where related figure text should be close on the embedding steps, and we hope that they can present it together on the same page. A text figure module also helps the post-processing, where we can filter out unrelated or add related but unused figures based on the similarity of the joint text figure embedding. Another one is paraphrasing module. Most sentences in slides are incomplete, should be presented concisely. So we rewrite the extracted sentence from paper as slide style. And this extractive then abstractive summarization can make the text content more concise and more adequate for presentation. In summary, the flow of our method includes HSE to decide the architecture and the content, text figure module to remove unrelated or add related figures, and paraphrasing module for concise and text content. For the evaluation, we also design different metrics to evaluate from different aspects of text only, figure only, and also text figure together. For text only, we consider the widely used root score to compare the text between our generated and ground truth slide. We further consider the length of slide by added weight here, which is the number of page difference, since a slide with too long or too short are both not well presented. For figure only, we consider the longest common order and calculate the typical precision recall F1 score as the similarity of figure distribution. And the important text figure, we consider the mean root score of text that has the same figure between ground truth and our generated. If the figure is in the ground truth but is not in the generated one, the score for that figure will be 0. In this way, we can encourage right figure should be put with related text by these metrics. And here is the overall performance of all ablation setting. The number in red color is the best one, and in blue is the second one. We first compare the baseline slide extractor and the hierarchical HSE. In general, HSE outperforms all aspects of text-only, figure-only, and text figures, which shows that the hierarchical progress tracker does help both text quality and figure retrieval. For paraphrasing module, it especially improves the text quality, leading to a higher root L and root score, because it can rewrite the sentence and make it into slide style. With the figure module co-training, both text and figure are improved due to a better correlation between each other. And the further post-processing by figure module can significantly improve the figure-only and text figure. As the goal of it, we want to present right figure with related text. And combine all of the techniques, including HSE, paraphrasing, and text figure, we can have a comprehensive improvement over all aspects of evaluation metrics. And here is some qualitative examples of our generated slides. And a comparison between with or without text figure module, we can add related or remove unrelated figures during the post-processing. And a comparison between with or without paraphrasing module. With it, we can have more concise and more slide-style text content. Currently, we follow a template-based position of the generated text and figure content, but we can make it more attractive easily through the Design Ideas function from Microsoft PowerPoint, which provides various pleasing templates to adopt. In conclusion, we introduced DOC2PPT, a multi-model summarizer that generates slides from academic documents automatically. We propose hierarchical slide extractor, text figure module, and paraphrasing module to improve the generated slide. And of course, DOC2PPT cannot generate a perfect slide currently, but it can provide useful outline and flow for humans to build a slide more efficiently. Here's Ray from UCSB. Thanks all of you listening about our project DOC2PPT.